CPU is a main component on laptop, right? CPU is a main component. Now CPU have a three department. One is called the arithmetic and logic unit. It's called the arithmetic, where he do the mathematical and calculations. All the binary instructions are there. He executes and make a decision. That is his first job. That is called a ALU, arithmetic and logic unit, where he do a mathematical and calculations, logical function. Second is a control unit. The control unit is a coordinator. The coordinate between the internal and external devices. Suppose this is a CPU. So we have some internal structures, internal department, ALU and cache RAM and this and that. So, and some external device also, so like input and output peripherals. So he coordinate between internal and external devices. So that the department who manage all the things, it's called the control units. And the next is called the register. The register means the small areas of storage, which is called the cache RAM. L1, L2, L3 is a storage. So that's to store the memory. Okay. So this is the processor, ALU, arithmetic and logic unit. And these are the register, store the memory, internal store the memory, and this is called the control unit. Okay. And this one is called the front side bus, where the CPU communicate with the external devices. CPU communicate with the external devices. Now, in how to identify on the motherboard which CPU is there on the motherboard. In desktop, see, CPU's pins are different. In previous days, CPU use a PGA chip. It's called a pin grid array. Then BGA, then the LGA. Normally CPU have only two types of pins. One is LGA and PGA. In laptop the PGA and in desktop the LGA. These are all the LGA sockets used on the desktop motherboard. Okay. So
PGA there is no desktop motherboard.
PGA there is no desktop motherboard. In olden days it was there, but now it's not there. In desktop, the pin is called the LGA 775. It's core to Duo processor or core to quad processor. Then LGA 1156. It's called a first generation processor. LGA 1155. Second generation and third generation is called a Sandy Bridge and Abbey Bridge. Then the fourth generation is called the Haswell 1150 sockets. And then LGA 1151 is called the Broadwell and Skylake socket. Fifth and sixth generation. So these are the, when you see the number on the motherboard, the socket number, so from that number indicate which processor is there on the motherboard. Understood? Then in a laptop, these are the main sockets. These are the main socket. For the core to Duo, all this is called a 478 MB. It's a blue type of socket. 478 pins there, and there's a 2 pins are missing here. This is called the 478 MB socket. In 478 MB, the processor use is Pentium 4 or Pentium M in old processor. Then there is a next socket, is called the 479. 479. The socket is a 479. One pin is missing. Here the 2 pin is missing in triangle. Here is a 1 pin is missing. The Pentium N and Celeron M. The next generation is called the 478 MN socket. It's called a socket P. Core to Duo socket. The 2 pins missing in this line. And the next is 478 MT socket M. Here the 2 pins are missing from vertically. So this vertically 2 pin missing means socket M, and horizontally 2 pin missing means socket P. So the processor are different. This processor can't go in this, and this processor can't go in this. And here is the socket is Core Studio Xeon processor use. Okay. So the after that there is a start from I generation processor, Core i3, i5, i7, and their generation 1, generation 2, generation 3, 4, 5, 6, 7. Yes, so these are different generation processor are there in a laptop, but in laptop there are only 3 sockets. One is RPGA 989, that is for the universal, only one pin is missing. Then there is a socket 988A, there is a 2 pin missing this side, 988A, where the first generation processor use.
These 3 also first generation.
Which one? This one. This you can do to any, one or two. In this only first generation will go. This 988B only second generation and third generation processor can go. And after that there is a no socket. Only soldered. All the processor are BGA format.
SOC.
No, BGA. BGA. There is a no socket. So these are the main socket in the laptop.
BGA, any problem it will come, we change total board.
We have to know, we can replace the processor.
But in general,
No, you can replace the processor. You should have a BGA machine and this
without BGA machine,
without BGA machine you can't do.
so board it will cost high now.
Here in India, here in Mumbai, the board costs start from 5,000 to
40% of the total.
5,000 to 15,000, depend on the processor.
Okay.
If you go for core i3,
7,000.
5,500, 6,000. If you go for
Including
including the processor. If you go for i5,
Okay.
the charge will increase, and if you go for i7, again the cost will increase. So it depend on the processor.
Generation also.
Yeah, depend on the generation also. So now we'll see how the Core Studio processor, what is the things he required to work. Okay, Core Studio, what he require, and how to identify whether the processor is functioning or not. First, the processor require, Core Studio processor require a 3 level of powers. That is require a VCCP voltage, that is a 1.05 volt, then VTT voltage, that is approximately 1.05 to 1.2, and the last, that is the CPU core voltage, that is in ampere. The voltage is approximately 0.8 to 1 and 30 ampere or above. So is required. So in our last section we seen how the VRM section work, how the CPU core section works. Okay, so these are the power to require processor to work. After that there is one more signal he require, that is a CPU power good. CPU power good is a confirmation signal that all the power which is he got, that is working, that is fine.
That is coming from IC.
That is coming from ICH. If the Core Studio, it is ICH, and in Core Studio it is ICH. And then he require a reset signal. The reset is also somewhere around 1 volt
MCH.
from MCH, 1 volt. So once the CPU get this reset signal, he release the reset signal, he ready to work. But before that he need a clock also.
Okay.
CPU need a clock also, a frequency to execute the instructions. Now the CPU have a parameter. These are the CPU's parameter, like here is mentioned 1.73. So 1.73 is a frequency, the clock frequency. Then 2M is a cache memory, the internal memory to work, and 533 is FSB, front side bus. These are the 3 parameters, and this one is the CPU code number.
Okay.
This one is the CPU code number, which CPU it is, whether it is well core, Core Studio, or Core Studio, which, how much its cache RAM and internal L1, L2, like that. So these are the requirement for the processor. Now how will I identify whether processor is working or not? The thing is कि once CPU get the power, the ampere which we have to use a DC power supply. My current should shoot up to about 10 ampere, about 10 ampere. No, sorry, not about 10 ampere.
1.5
About 1 ampere. Above 1 ampere current should go above 1 ampere. And if you have oscilloscope, you can check this signal. It's called a B clock ITP. If B clock ITP coming on the oscilloscope, that means CPU is responding. Then you can check this signal also, SVID, on the oscilloscope. This signal you can check only on the oscilloscope.
Yes.
You can't check multimeter.
Yes.
Frequency.
SVID, B clock, this signal you,
And clock.
and clock, all this signal you can check only with the oscilloscope.
This FSB.
FSB also you can check with the help of oscilloscope. You can't check on the multimeter.
Without oscilloscope.
And if these signals are
Is it
coming,
possible to check FSB?
FSB, no, most of the motherboard, what they give some test point.
Okay.
I'll show you on the diagram. They give the test point where you have to connect your oscilloscope. They give the debug port. It's called a ITP debug port. There you can check all the signals. You can check this ITP B clock. You can check clock like that. And if these signals are coming, that means CPU is responding. So like that. So this one is called the core to duo processor. Now after that there are different processor like introduced in 2009 and 2010. The different processor introduced Core i3, then i5 and i7. It's what is a Core i3? Now in 2009, what the Intel did it, he cut this MCH, okay, he cut this MCH, and the half portion of the MCH he put into the CPU memory module. So now what has happened is memory directly connected to the CPU. Memory directly connected to the CPU. So in previously when there is a MCH, what CPU has to do is, when he suppose if he want to write some file, he has to request to the MCH, this is my file, you give it to the memory. And when he requires something file, so he requests to the MCH and ask, I want some file.
Yes.
So what the MCH take a request and collect the file from memory and again
Go through MCH to
go through MCH. So lot of nanoseconds are waste. Lot of nanoseconds are waste. And the benchmark will reduce. So that is why what the Intel did is, so he cut that MCH and the memory controller he connect directly to the CPU. So the access time is very fast.
Very fast, yes.
Access time is very fast. So there is no need to request to the MCH for the memory. So immediately whatever file is he kept and wherever is required he just left.
Yes.
So it's a very simple. And this graphics controller, what he did is he put it into this south bridge, and even this clock section also he put it into the south bridge. So there is a no clock, he kept it into the
On chip.
on one chip, like this is your ICH,
Yeah.
okay, and this is my graphics controller and this is my clock chip. So all together become a single chips, that is called a platform controller hub or called a PCH. Okay, that they did. And for that, to communicate all the chips, they make another processor, that is they introduce a 3 processor, that is i3, i5 and i7. So I'll explain you the what is the difference between the i3, i5 and i7. You understood this?
Yeah, sure.
PCH उसमें अपना खुद का BIOS IC अलग से होती है ना अभी.
Wait. So now this is chart which describe the what is the difference between i3, i5 and i7. So there are four basic difference between the i3, i5, i7. The first difference is number of cores. Number of cores means number of arithmetic and logic units. If there is a single core, when the instructions coming from outside the world, the one person is managing all the instructions. Now we put two people to do the same job. What will happen?
They share both.
The work will divide to the 50% this and the 50% this. Then performance will
Increase.
boost. So similarly, the number of cores in Core Studio there are 2 cores. So the 2 cores were there. In Pentium there is only cores. So compared to the Pentium, Core Studio is a double, much faster than Pentium. Now here in Core i3, the in Core i3 there are 2 cores, and Core Studio there are 2 cores. But what is the difference between Core i3 and Core Studio? The managing the memory architecture. So Core i3 is a faster than Core Studio. Why? Because managing the memory.
Yes.
In Core i5 there are 4 cores in first generation. So here is a double speed.
Yes.
4 people are there to do the same job.
Yes.
And Core i7 4 core again. The next section is the threads. Thread means how they are perform, how they function, how they act. So the Core i3 is a double threads. Core i5 is a 4 threads. So it's a much better. And i7 is a 8 thread. So here is a i7 is a much better and much faster and much give better performance. The next is the turbo. i3 doesn't have a turbo. i5 is a 3.8 turbo and i7 is a 4 gigahertz turbo.
It is used for the turbo.
Turbo means the speed to increase.
when there is load.
When there is a something speed and they want a more speed, so he can boost their speed. It's called a turbo. Then there is a cache, internal memory. There is a 3 level of memory, L1, L2, L3. Cache memory. So Core i3 is a 3 MB cache memory in first generation, i5 4 and i7 8. So these are the difference in i3, i5 and i7. And still it is improving. And then there is a next thing in the processor that is called the generations. The generation means they improving the processor, cache RAM, speed. Then there is called a TDP. Then the power. Power is slowly reducing.
Yeah. Heat reducing.
Heat reducing, that is called a TDP reducing.
And technology NM.
Cache RAM increasing, frequency increasing, ALU increasing, size decreasing. So these are the difference in the generations, right?
14 NM.
So these are the difference. Thermal design power, then number of processor core units are increasing, then number of cores are increased, cache memory increase, and turbo speed. So this is my first generation processor which is introduced in 2010. It's called the Westmere. In that my north bridge is integrated. North bridge half portion which is the manage the memory controller is integrated into the processor. The socket number for this processor is a 988A. It's called a generation 1. In last screen we seen the 3 types of sockets.
Graphics also is there.
graphics is there. Yeah, but work through the PCH only.
Graphics.
Graphics. Then if this processor, Intel introduced two processor. One is in the socket, another in the BGA. One is a socket, okay, and another is in the BGA. If you have the BGA, its pin number is 1288. 1288. Okay, so this is a 20% faster than Core 2 Duo. Then there is a next processor, it's called a Sandy Bridge, second generation processor, generation 2 processor. In generation 2 processor, the socket number is 988B. In generation 1, 988A. Here is a 988B, and if it is a BGA, 1023, and there 1024. 1288, here 1023. So this processor included graphics into the CPU. Graphics integrated. Cache is increased 10% faster compared to the first generations. And these are the voltages required to work this processor. It require a CPU core, graphics core, 1.05, 1.5, 1.8, DDR3 supported.
Okay. So 1.5 volts.
1.5, yeah. Then there is a third generation. It's called the Ivy Bridge. Third generation, same socket 988B, BGA 1023. Here is the process time is reduced.
22.
Process time is reduced. The process time means the processor, the CPU is made by combination of MOSFET. It's a combination of FET, and this FET size is determine the power and the heat. And if you go reducing the size of the FET, which reduce the power and the heat.
Yes.
If the FET size is more, heat will more, power is more. So this is called the nanotechnology. NM means the nanotechnology. The previous Core 2 Duo is a 48 nm. Core i3 is something 32 nm. And this third generation is a 22 nm. So he reduced the power, reduce the heat. So this processor in those days it was used for ultrabook. In those days there is ultrabook, slim. Okay. So the 50% power reduction. And the next processor is called the fourth generation Haswell. From here all the BGA chips is there. Haswell, Broadwell, Cabby Lake, Coffee Lake, all the Lake. They are all the BGAs. There is no socket. In this processor, what they did, they integrated graphics and integrated PCH also. There is no need of North Bridge, South Bridge, PCH, graphics, clock. No need. Everything integrated into the CPU.
Okay.
And CPU is a soldered. Okay. So it's a double graphics performance and integrated graphics, integrated chips, and it's a better performance, give more power reduction. And the fifth generation, that is called the Broadwell, which is a 14 nm. 14 nm, that is a Broadwell processor, fifth generation. Then
Remaining all regulators also in CPU only.
which one?
SATA controller and
Everything.
in CPU only.
USB, SATA, PATA, audio, PCI, everything is integrated.
So only one chip is.
Only one chip will be there. So there is a no clock, there is a no graphic, there is a no PCH, there is a no SATA, there is a no your USB controller, everything is integrated. Audio, network, of course network chip is there, audio chip is there, but main controller is inside the processor. Main controller is inside the processor. So these are generations. Now this Core i3 series test pin will see what are the things we require. First you need the power, right? First you need the power, that is the 1.5, 1.8, 1.05, 0.75. This is the power you need. And last you need the 2 core voltage, that is the CPU core, and another is a graphics core, because the graphics is inside in the processor. So you need a graphics.
Okay.
Then you need a DRAM power good. You need a CPU power good and need a CPU reset. These are the input things is required to work. These are the input thing is required to work. He received this signal from the PCH. He received this signal from the processor, right? And he received this clock from PCH only, because clock again into the PCH, again into the PCH. So this is a B clock ITP. This signal you can check with the help of oscilloscope whether this processor is working or not. Okay, and these are some test points where you can check whether processor is working or not. Number 1 is a DRAM reset. Once processor receive this DRAM power good from the PCH, he release one signal, that is a DRAM reset. This signal you can check on RAM slot pin number 30. A RAM slot pin number 30, you should get a 1.5 volt. If it is a 1.5 volt is coming, that means this signal is pass and processor mostly working. This VID signal coming means CPU is responding. This signal you have to check with the help of oscilloscope. This signal you can check with the help of multimeter. And the next is called CKE, clock enable. When CPU start communicate with the RAM, he release one signal, that is called a clock enable at the RAM slot. And if this signal is coming, that means CPU starting communicating with the RAM. And finally you can check the clock also at the RAM pin, and if this clock is coming, that means CPU started, CPU is perfect. And in this way you can assume whether CPU is working or not. And finally CPU have a 2 communication protocol, like in Core Studio processor there is only one bus, it's called FSB, front side bus. Front side bus where CPU communicate with the north bridge with the FSB. Here there are 2 buses, one is called the DMI, another is called the FDI. DMI is the direct media interface, which is a bus communicate with the with the PCH. With the PCH is called the DMI bus, all the data. And there is a separate pipeline. There is a separate pipeline for the graphics. So not integrated into this traffic. There is a separate route that taken out for the graphic signal is called the FDI, flexible display interface. This flexible display interface is another communication protocol between the processor and the PCH for the graphics information. So these are the things to processor.
This is the first generation.
For first generation, first generation, second and third. And in fourth, there is no PCH also.
Yes.
For first, second and third, the same concept will work.